we actually started talking about this storage system almost exactly a year ago. And it has been a very interesting and intense exercise, and I would like to share the results with you. We find it very exciting, what we learned, and as a matter of fact, I'll tell you the story about what happened before. So, but before I want to start about what it is we're going to do, I want to tell you what SSERCA is. So I'm here, I actually am part of the University of Florida, but SSERCA is the organization that did this work and that is going to be the beneficial. SSERCA stands for Sunshine State Education and Research Computing Alliance. It is a group of voluntary collaboration. So we don't have any big grant that sort of funds us from the top. It is people who got together and realized if we do things together, if we share information, if we put in some effort, we will benefit whether we get some external money or not. Now, of course, we are hoping that by showing this extra efficiency, we will get some funding for some of our projects, and it looks like we will, but that was not the goal. And I think that was very important because that meant that people actually are willing to put in the work. They're not just coming and saying, oh, you know, I can get some benefit out of this. The organization grew with what are now called the members. And the distinction between the members and the affiliates is that the members are institutions who already have on their campus an HPC center or a research computing service center providing services for supporting research computing as opposed to general IT on their campus to the entire campus. Most of the universities and even these 6 have still research groups that have their own cluster, but we were talking about a real organization that supports, in principle, every faculty member and their research team on their campus. And so we have FIU, Florida International University, Florida State University, University of Central Florida, University of Florida, University of Miami, which is a private university, and University of South Florida. All of those are state university systems. So we are representing quite a swath of the state. And then the affiliates are Florida A&M University, Florida Atlantic University, Florida Institute of Technology, and University of North Florida. And one of the reasons we can do this, and this is actually where SSERCA grew 3 years ago, is the glue is our regional network provider, the Florida Lambda Rail. The Florida Lambda Rail is an organization that actually owns, or mostly owns in a very long lease, fiber that was left in the ground after the big bubble of 2000. And so they bought, and the universities, all the universities that are listed there are members of Florida Lambda Rail as an organization, partial owners. And what we realized 3 years ago was that in order to really get to the next level, we need to provide more services than just moving bits. And that is where SSERCA comes in. SSERCA wants to provide actual expertise to bring high-performance computing, big data analytics, all these things that 3 years ago were just growing, but it was a growing need. How do we make more users make useful and effective use of all these resources? Because the group of traditional hardcore scientists and engineers who've been doing it for years is going to be there. They will be there forever, but they are not growing. And there is a growing need across the entire spectrum of human activities for more high-performance computing. But these people will not have the time, simply because of the complexity of their own tasks, to also become computer specialists. So we need to provide more advanced services so that the use of all this technology is useful and can be effectively deployed in larger community. So we created SSERCA to enable and enhance collaborative research. That's our initial focus. There are lots of people across the world, and we see this in our state, where you no longer can have one faculty member or 2 or 3 faculty members at one institution collaborate and do some really state-of-the-art research. They will find that they need another collaborator, and the chances that they have such a collaborator on their campus are getting smaller and smaller, and people are more and more led into collaborations that are over long distance. Unfortunately, the technology of moving data, fast worldwide networks, is growing, and so that is possible. And we basically said, we will try and help make this infrastructure ready to go so that people can come to us and we can say, oh yeah, we can do that for you, and it will not take 6 months or 2 years, which is the entire duration of their grant, but we will be able to do this in a matter of days or weeks. That's our goal. And then once we do this, we also believe that we will make them more competitive. If they can do this more quickly and they can just write in their proposal, there is this infrastructure, we are people from 2 different universities across the state or across the world, across the nation, and this infrastructure is just ready. We can allow them to write a little paragraph in their proposal that says, this is how we will make this work, and all this staff is already there. These people know what they're doing, they're professionals. I do not have to hire them on my grant. I can put them in my budget. This is their cost. These costs are very reasonable and competitive, and it doesn't become an obstacle. They are more competitive. That is what SSERCA is about. So now we then wanted to answer to the innovative storage infrastructure proposal for NSF 13528 for a national resource for storage. And the reason we thought it was interesting and worthwhile for us to do this is because we had been getting these requests from all our users that they wanted a storage infrastructure that was easy to use, that was reliable, that allowed them to collaborate easily, and that did not require them to become computer scientists before using it. So that is where we have the sort of general principle and vision of our proposal, and we wrote a proposal, and I'll tell you what the proposal is. We actually didn't get funding, but we all believe that the solution is so useful that we're going to implement it anyway. And we just finished an ITN, invitation to negotiate, and we will go ahead and purchase this system, not at the full scale of the proposal, but it will not cover the whole nation because it's not an NSF resource, it'll be a statewide resource. So what is the important thing of our infrastructure that we'll propose and that I will now describe to you is we want to address the need of actual working researchers right on. We do not really want to center on some particular hardware or software design, but we want to be in the business of helping them out in the long term. We want to make sure that both small institutions and large institutions can quickly jump on board without having to make huge investments. We want it to be naturally extensible so that if somebody later says, oh, this is great, I can start working with you guys, but it works so well, I want to improve it. Can I buy something that will make it better for the people on my campus? We want it also to be intrinsically sustainable, and we want it to be open for new approaches. Then one of the things that we thought was a pretty good example or strength of our proposal was that the state of Florida, with all these institutions, is a pretty diverse group, and it's a little bit of a microcosm of the entire nation. So we have researchers with needs that really cut across the entire range of what NSF wanted to propose, and so that's why we worked on this. We also wanted to provide a long-term roadmap so that we not only have a solution, we made a design, we not only have a solution for the immediate need as perceived by our researchers, which is how do we support the research that is actively going on, actively being supported by grants, but also provide a way so that after the grants are over, the data still has a way to go in an affordable mechanism and can be kept up to date. One of the problems that most funded research now is facing is people are required to propose a data management plan that sort of specifies what will happen to the data after it's done. And they create websites where the data is available. And then what happens is after a year or so when the grant is over, these websites grow stale and they don't work anymore and there is nobody to really look at them and or they have to get shut down because there is a security problem and there's nobody who can update them and they sort of wither away. And that doesn't really meet the need. So one of the things that we then wanted to propose is a storage system that can also provide not only a general collaborative storage framework, but also links to the high performance resources that NSF Exceed already provides, and in our context of SSERCA, that the 5 members provide. So we want to have a storage infrastructure that can be used across the state by all institutions that are linked by the Florida Lambda Rail, but that can then use the resources, the high-performance resources that are operated by those institutions that already have them. So what I will try to answer are these questions. What challenges are we addressing? What is the proposed project and that we will build? How are the Exceed resources leveraged? Or how the HPC resources going forward in the immediate future. And then what are the particular features? In what way are they sustainable, extensible, and flexible and adaptable? And then what can other people do to build upon this once we put it in place? What are the current challenges for storage providers? One of the things that is happening with the research activities across the entire range of scientific and scholarly and engineering activity is that you get multiple sources and multiple sizes of data. There are some groups that generate huge data sets, others generate small data sets, but very large numbers of them. And they have different origins, different needs to manipulate them. So there is a natural and very wide diversity. Then there are multiple places where the data gets stored. Some data comes from an instrument that lives on a particular campus, but then you have a collaboration with other people. Then other organizations are really worldwide organizations that try to collect data from all over, and then they want to have the research community have the ability to look at everybody's data and compare them, because the real value is not in the data that was collected at site A or at site B by itself, but it really becomes interesting when you can compare all the data that everybody has. And of course, there is one way to look at this and say, well, let there be a super granddaddy who takes all the data and then everybody just works there. But that doesn't really scale. And it also has the problem that not everybody wants to just part with all their data. So there has to be a democratic way where everybody feels comfortable that they're contributing and benefiting from being in a collaborative network. And that requires a complex infrastructure. And then finally, that's the source of the data. There is multiple actions and timescales of data that people want to do. Some of the analysis is very compute intensive, which means that you have to somehow bring the data close to some high performance computing facility, and their computations may run for days or at least multiple hours. Then you need to make the data available. You want to have large communities. Some communities are not that large, but other communities are. And if you want to build a good collaborative research data infrastructure, you have to have all of that. Then the accessibility is also not a yes-no answer in the sense that, oh, I want to share my data, it's okay, here it's all public, or I don't want to share my data at all, and then I just keep it in my little hard drive on the shelf in my lab. We have to have a rich choice because there are people who have really particular needs and particular requirements of how to share the data, and they have it for good reason. And there's no reason that we, with our technology, should dictate how they work with their data. It's like, oh, well, if you don't want to do it like that, then you just can't play. So there are groups who want to be able to share some data completely public, some data with some relatively large group where the user can very easily register with an account and then they have access to the data. Others where you really want to make a request to the PI and say, I want to have access to the data, and the PI thinks about it and talks or whatever, and then you get access. All these mechanisms have to be available if you really want to talk to a large community and be useful to all their needs. And then there is the timeline that there is a phase where there's initial just raw data, then there is data that people are working on. There may need some collaboration during that work, that collaborative, that sort of working on phase. And then there's the final phase where the data is done, where you have, or the work is done, and there is a particular well-defined publication, and then the result of that publication leads to data that is now unrestricted, available, or available to a larger group. In addition, people may want to have data that is active, so that once you have the data, the publication is there needs to be a website that is still connected. It's not purely static, but it's still connected to some storage, and creates, allows the user to do some processing. So, we want to have an effective environment involving large and small data. So we want to bring these things together, and we want to have an interactivity and instant gratification to use the cloud as an example. So what we proposed is the Extreme Digital Extensible Storage Ecosystem, XDs. That was the name we gave to our proposal. And the supported and funded core was a system that was distributed by design, multi-access, multi-process, multi-owner. It leveraged Exceed resources, and it had the typical process. So here I want to show sort of the overview. You basically had one storage at one of the sites, and then another site. There's a data gateway. We had the Exceed integration, and the researcher can access it from anywhere through the internet. So one of the things that we thought was very important is that once the system is put in place, other funding can be used to build other building blocks. So by showing the system from the start as a distributed system, we would prove and figure out all the mechanisms and the know-hows and the best way to operate it, best practices, so that people could just say, oh, I want to join into that network, and geographically people can add on a little block, or people could organize by an organization, create like a virtual community and say, hey, we want to be part of this, or we want to use this functionality. And even there's no reason from the architecture that we cannot have some public data. Of course, all the research should be public data if it's NSF funded, but there could also be some other funding that allows you to work with restricted data. And then archival data can be built on later. So the structure that we proposed was in partnership with DDN, a WOS storage system. And we basically had a WOS core storage at each of the locations. The WOS would provide policy-based replication, which would allow the researcher to specify from a set of available policies, I want this data to be available and replicated from this university to this other university where my collaborator lives, and so that data is automatically replicated. It gives them the backup facility that the data is replicated, and it also gives them the ability that the other user can see the data. With WOS Access Gateway, people can still mount the data locally on their workstations through CIFS, and using the gateways, we can have either with connection with Gridscaler or Lustre Exascaler to the HPC systems, so that the data could be used as a second tier for high performance storage, and that would give the data would be sitting there in the distributed file system, and it would be possible to do high performance computation on it on whatever HPC system that is accessible to the researcher. So one of the things that we also proposed as an exceed built in is, for instance, by having a WOS bridge here, the Stampede system could see the storage, and the WOS system would just make sure that the data that is synchronized or needs to be synchronized is synchronized, and WOS actually has the caching mechanism built in, so that data that is accessed the first time may not move as fast, but then once the data has been replicated in this location, then the calculation would move fast, and the user could still see the results, again, not in a totally synchronized way like it would be in a worldwide file system, but that doesn't have to be. Most requirements for research are that they want to see the data in a reasonable time, like overnight or a couple of hours or whatever, and that still would allow and enable collaboration without the pain of having to move the data. So that is what we allow as a mechanism to manage exceed resources. And the data could be moved with tools like Globus online, but you could also just let WOS do it itself depending on the researcher's planning. And that flexibility, that there are multiple ways for people to sort of figure out whatever their workflow is, would make this system, or does make this system, a very desirable one. So this is one of the things that we were saying. You can transfer the file very fast, and then you get optimal performance, or you can just let Exceed do it, and DDN WOS core will then figure it out itself. And that would allow, in addition, that would allow the very experienced HPC user to really optimize the workflow if they have to, but it would also allow the inexperienced user, or the user who really doesn't want to delve into the details, to get work done. It would just work behind the scenes, and it would be fine. And the partnership, as I said, DDN is an important one, and of course our network partner is the Florida Lambda Rail, which provides the connection between all the sites in the state of Florida, and then to Internet 2 to get across the nation. And we have for data, so this is an overview of the state of Florida with all the universities and the different systems that we proposed. And what is happening now, so like I said, the proposal is not funded, but we are seeking independent funding from the state of Florida for building this system anyway, and so far we've gotten some very good reviews from the Board of Governors and also from the Office of the Governor, so we're actually still optimistic that we may get this project funded after all. But even independent of that, we are going to build pieces of this infrastructure in the next 3 to 6 months. So a quick overview, we have at each SSERCA site a storage server, the WOS building block, with specified capacity here. And the most important thing that our researchers really like is to have this multiple way of getting to the data. They would be able to share in a Dropbox-like interface data without having to interfere or work with complicated institutional authentication mechanisms. They can just go and create access to a particular folder for a collaborator at 10 o'clock at night, and it will be right there. So the architecture is the typical details. I can give you that in more detail if you want to, but one of the important things is that we have multiple racks and they all are connected through the Florida Lambda rail. So one of the things that we really are thinking this is an important breakthrough, or for us it's an answer of a long-standing set of questions of how to provide storage for collaboration, an easy user interface, composability of data flows that integrate with workflows. We have multiple authentication domains are possible. It's easy to share data, and we can include data from instruments as needed. So this is just a repeat of the same. And the authentication is very important because one of the things that we realized very early on is we were trying to build a statewide authentication mechanism, but it turns out that not all institutions make it their highest priority to build this infrastructure, and that would mean that some researchers could not collaborate with some other researchers if that institution doesn't have the same authentication mechanism. So after trying for a year of getting a global infrastructure, we had to give in and say, look, if we don't want to be exclusive, but if we want to be inclusive, which is what we want to, we have to be able to enable anybody to play in whatever way is available to them. We cannot make a complicated requirement, even though it is good. And I'm a believer in worldwide authentication and in InCommon and in EDUCAUSE. They are very good, but there are institutions, especially the smaller ones, who need the extra help of being able to collaborate with others. If you put this hurdle in front of them, then it sort of defeats the purpose. So we don't want to do that. That's very important. So that's what we want to basically enhance and increase innovation. I already explained that the system is extensible and sustainable because people can build extra building blocks with extra funding that doesn't have to be from the same general funding. And I have a couple more slides that I could go over as a use case, but I'm running out of time, so I think I'll just leave it up, let people some questions. Okay, so just to say, how does this system work for a general user? So Alice has a project that involves data from an instrument, and more data is generated by analysis and modeling. So she gets an allocation on our storage system. She arranges for a data flow to the storage from the instrument. The data flow can demand it. She can set up some complicated staging rack, or not a complicated one, but if there is a very high performance from the instrument, but very often we find, like for instance, if it's a gene sequencing, the actual stream of data from the instrument itself, the first time the data comes off, you can deal with a 1 gigabit connection. And so there is a very good way that she can get the data and just move it to the central storage. And once it's on the central storage, now on one of the storage, like the most local system, then the Florida Lambda Rail and other networks connected and make it sure that other researchers and high performance analysis systems can get to the data quickly. So then she can use things like Galaxy to control the workflow of working on the data, and the data is now on a system that is seen by the high performance system. She can control it from wherever she is, even from an iPad while she's traveling. She doesn't have to be at a high performance place to control the workflow, because her data is at part of the network and it's on a safe storage place. And now she can basically go and have the data work, look at the results, ask her colleague to look at the same data, and the colleague can control other workflows integrated in their allocation, and so that's how they can share their collaboration through that persistent storage that is distributed. And this is another use case for long-term lifecycle management, where you put the data first in the shared storage, and then you can later on transition it to compatible systems. And one of the things that we're trying to do at the University of Florida, for instance, is we're going to build this system. We have our own node, and part of the allocation will be our institutional repository that's managed by the library. And so the data can just be tagged as, oh, now it goes from the storage that is funded by the grant of the researchers, and it just moved over with a simple policy statement or an automatic control to the campus, and maybe not all the data, but the data that they want to make published will be available in the institutional repository automatically. So that's basically the move that it gets it then all the way to the archival.